Okay, is this better? Ah, that is better. That is much better. Well, it is now 1:56. I've lost a minute, and I had too much to cover in an hour. So I definitely have too much to cover in 59 minutes. So I'm going to get going. So first, hello everyone. I'm Ben Armstrong, Program Manager on the Hyper-V development team. And I'm here today to talk to you about what's new in Hyper-V in Windows Server 2012 R2. But first, I do want to do a quick little recap. So the first thing I want to talk about is Hyper-V in 2012. This has been a huge release for us. We've seen a lot of customer adoption and uptake, and we've heard a lot of positive feedback. But one thing that I really want to highlight is I have lost track of the number of people who do not realize all the things we did in 2012 because it was such a big release. I think most people got halfway through the launch of Windows Server 2012 and their brains just shut down and they couldn't take in any more information. Literally yesterday afternoon, I was meeting with a local company talking about Hyper-V in 2012 R2, and as I'm talking about this, they're asking me questions about different areas and going like, hey, are you guys ever going to do something about X? And I'm sitting there going like, yeah, we did something about that in 2012. That was the last release. So there are really two things that I'm asking you guys to think about on this slide. The first one is, I know lots of people who looked at Windows Server 2012 and went, yeah, I'm going to use replica, I'm going to use the network teaming, that looks pretty cool, but that SMB3 and scale-out file server stuff, yeah, another day. If you're one of those people, like I would ask you, think about the things that you've put on your another day list and go back and have a look at them and just have a refresher. I would also really encourage, we did a lot of speaking about 2012 last year, there was a lot of stuff recorded. I'd really encourage you just, go up to Channel 9, look at last year's event and, re-watch some of them, re-skim through some of the slides, just to make sure that you understand everything that's there in 2012 so that you know how to get the most value out of it. The next thing that we've announced recently with 2012 is something that, as a guy from the Hyper-V team, I'm really proud of, I'm really happy about, is that we now have Windows Azure running on stock Windows Server 2012. So to give a bit of context here, Windows Azure has always run on the Windows Server and Hyper-V code base, but they've made their own version of it and they've made their own modification because they've been doing things at scales that we just didn't design for. An Azure data center has hundreds and thousands of physical computers in it. So this has been something that we've been working with the Azure team together for a while now, and it's always been our goal to get to the stage where the Azure team was able to use stock Windows Server with stock Hyper-V, and we got there in the last 6 months, and that's really exciting from our point of view. For you guys, that means two things. One, hey, the stuff you run is the stuff that we run in Azure, and I think that's pretty cool. Two, it means that if you're someone who's looking at, hey, I'm running virtualization on-premise right now, and I want to make sure that I'm not, excluding myself from public cloud or hosted cloud in the future, we're in a really good place now because we have the same platform in both locations. The final thing I want to touch on before I start diving into details is kind of building on what I just talked about. One of the big things that we're pushing towards at Microsoft is this idea of hybrid cloud computing. Right now, I talk to people and the conversation tends to really be about like, well, we looked at whether we could do public cloud or private cloud and we decided X. And the reality is we don't think that's where the conversation needs to go. Because the reality is for most people, we think that the right answer is to use all forms of cloud when it makes sense. So we kind of have two goals from the development team in this. The first one is, right now, when people look at like public cloud versus private cloud versus hosted cloud, part of the conversation is a business conversation. Part of it is, we have regulation control requirements, we have data control requirements, so on. Part of the conversation is a technical conversation. If I do an on-premise cloud, I have these technical capabilities. If I do a public cloud, I have those technical capabilities. If I go with a local service provider, I get a different set of technical capabilities. So from the engineering side of view, we have two goals. One, we want to make those technical differences go away. We're pushing we want the conversation of, does this workload run on-premise, off-premise, public cloud, private cloud? We want that to purely be a business and dollars conversation. We don't want technology to be involved in that at all. The other thing that we're really working on is we want to make it easy for you to change your mind. We want to make it easy for you to go, 3 years ago, private cloud made sense for me, maybe not so much now. 3 years ago, we went with public cloud, but now we need to bring some of it on-premise. We want to enable all these sorts of scenarios so that you can get the most out of cloud computing. So, with that backdrop, what have we been doing in Hyper-V with 2012 R2? Well, there have been a couple of areas of investment. 2012 was a big release for us, and we were really excited to get off of 2012 and to turn around and do another big release. I've been talking to people, and most people, when they started hearing the rumors that there was going to be a 2012 R2 release coming out, immediately kind of filed it away as like, it'll be a service pack type release. There'll be a couple of little features, but mostly just bug fixes. And 2012 R2 is a huge release for us. And I'm really, I'm excited to see it go out there and see how people react to it. But there were a couple of areas that we looked at. One area that was particularly interesting for us was we actually kind of took a step back and said, we've got a lot of stuff going on here with virtualization, there's a lot of momentum, but what are some things that we can do that really change the game with virtualization? What are some new things that we can do, some new approaches, some new mindsets that we can take? And there were a couple of technologies that came out of this, which are quite interesting. So the first one is what we call the Generation 2 virtual machine. Now, I've been working in virtualization for just over 12 years now. And 12 years ago, when I first got involved in virtualization, virtualization was a crazy thing for nutcases. You wouldn't use virtualization on x86 computers. And so a large part of what we did with virtual machines was we did a lot of work to try and make a virtual machine look just like a physical computer. Because no one would do any work to make their software run on a virtual machine. So we had to try and make ourselves look like a physical computer, which was great 12 years ago. But today, the world's a different place. Today, over 50% of new server deployments are virtualized. Today, we talk to customers, and they tell us, yeah, we virtualize first, we virtualize by default, and if you don't want to virtualize, you have to have done your homework and explain to me why this workload shouldn't be virtualized. Today, Windows as an operating system is innately aware of when it's running on a virtual machine. It knows when it's running on a virtual machine, and it behaves differently in order to perform well inside of a virtual machine. So a Generation 2 virtual machine is a virtual machine where we put away all of the pretense of pretending to be a physical machine, and we just say, you know what? It's just a virtual machine. Like, no emulated devices, no goofiness, pure virtual machine. So I'll show you what that looks like in a moment. The next thing that we did was we did a bunch of work improving the experience for interacting with virtual machines through the Hyper-V tools. I'm not going to talk much about this here because it's more fun to demo. The final thing that we did is something that's impossible to demo, so I'm going to talk about it a lot. Is a feature that we call automatic activation. So a long time ago now, I actually had to check when we started doing this. It was Windows Server 2003 R2. So Windows Server 2003 R2, we came up with the idea of, hey, we've got standard enterprise and data center, and we've got all these SKU differentiation and all these features and knobs that we can offer with this. We should add to that mix the concept of guest virtual machine licenses. So Windows Server 2003 R2, we said standard edition comes with one virtual machine guest license. Enterprise edition comes with 4 virtual machine guest licenses, and data center comes with unlimited. And let me tell you, we have never sold more copies of data center in our lives. It was actually, there was some shock and awe from the licensing team because prior to this decision, data center was very much a niche thing. And all of a sudden, everyone was, deploying data center in order to get the, unlimited Windows Server virtualization in virtual machines. So fast forward to Windows Server 2012, this has been so successful that today, Windows Server 2012, the only difference between standard and data center is how many virtual machines you get licenses for. There is no other SKU differentiation. So if you want to build a cluster on standard edition, fine. You want to run any role on standard edition, fine. In fact, we even have the free Hyper-V edition, which has everything in it. It has remote FX, it has Hyper-V replica, it has live migration, it has clustering, it has all the features. It just doesn't come with any virtual machine guest licenses, which is why we give it away for free. So that's really cool, but with Windows Server 2012, you still have to do key management for those virtual machines. Yes, from a Microsoft point of view, we're happy, you're licensed. You got data center, and, from an accounting and balancing the books, good stuff. But from a day-to-day nuts and bolts, you still have to do key management. Now let's do a show of hands. Who here likes doing key management? No one. Actually, last time when I asked this question in TechEd Europe, I had one guy raise his hand, and I picked on him, and it's like, I'm a consultant who sells KMS systems. So he loved them, and he wasn't very happy to hear about this. So in Windows Server 2012 R2, what we've done is we've built infrastructure on both sides of the fence so that when a Windows Server 2012 R2 virtual machine comes up inside of a virtual machine, it can actually reach out, talk to the host in a secure fashion, and say, hey, are you an activated copy of data center? And if it gets the answer back, it goes, okay, we're done, I'm activated. Nothing for you to configure. As I said, it is the worst demo in the world because I bring up a VM and go, look, it's activated. But it is really convenient. It's a lot less work for you guys. It also makes a lot of different scenarios easier. If you've ever had a situation where you've had to move a virtual machine between different businesses, you know that key management and keeping licensing clean is a real pain. With 2012 R2, you create your VM on a licensed activated data center. You don't actually put a key in there. So it doesn't have your key, it doesn't know about your key. All it knows is I'm running on an activated host. You now need to take that VM and give it to someone else. If they put it on a copy of data center that's also activated with their key, then the VM comes up and it's fine. If they put it on, Hyper-V server, or they put it on, a Windows Server standard, then it's going to come up and it's going to ask for them to provide a key. And this all happens with no effort on your behalf. So with that, let me switch across to my demo system and show you some of the stuff I've been talking about. And yes, for those with quick eyes, I run my own demo domain. I call it Ben, and I create an admin account called Ben, so I am logging in as Ben on all these systems. So first thing I want to show you is a Generation 1 and a Generation 2 virtual machine side by side. And creating these machines is quite simple. In the experience with Windows Server 2012 R2, when you open the new virtual machine wizard, there's now just a page in there where we ask, hey, are you going to create a Generation 1 or a Generation 2 virtual machine? Apart from that, it's largely unchanged. So here I have my two virtual machines. Look kind of the same. But if I bring up Device Manager, what you're going to see is this is the Generation 1 virtual machine. And you can see there's a whole bunch of stuff in here that just doesn't belong here. I've got my PS2 mouse. I like this, I've got my PCI to ISA bridge. When was the last time you used an ISA card? I like this one. So we emulate a 440BX motherboard. So here's my Pentium 2 processor to ISA bridge. Let me tell you, we've actually found some interesting bugs in various operating systems out there because we emulate a 440BX motherboard, that chipset was released in '95. It was a Pentium 2 processor chipset. And we do this for maximum compatibility, but now we actually have times when you create a really large virtual machine and we will report that we're a 440BX Pentium 2 motherboard with 64 processors, which can cause some confusion. But anyway, so there's all this stuff here. Now if I come over to my Generation 2 virtual machine, none of that's there. I basically have VM bus and I have devices associated with VM bus. So, that's cool, it's nice, but what does it mean for you as the user? Well, it means a couple of specific things. And I do want to be open and honest about this. This is something that we're building as an interesting platform that we have ideas for moving forward. In this release, there are some specific advantages to Generation 2. And I want to be really clear about that. So the first one that I like to show is let me bring up VM settings for my Generation 1 virtual machine and VM settings for my Generation 2 virtual machine. And you'll notice that there's a lot missing from the Generation 2 virtual machine. And that's because there's a lot that's no longer needed. We don't have IDE controllers because we can now boot off of SCSI. We don't have legacy network adapters because we can now Pixie boot off of a virtual network adapter. So from a configuration and flexibility point of view, this is a lot simpler. So that's a win. The other thing that's a nice thing about Generation 2 virtual machines is in order to make this fully virtualized virtual machine, we actually created a UEFI-based virtual machine rather than the traditional BIOS-based virtual machine. And the fact that it's UEFI-based means that we actually get support for secure boot inside of the virtual machine. So if you're running Windows 8 or later, you're protected against kernel mode attacks. So let me close that down. Because now I want to move on from Generation 2 virtual machines, and I want to talk to some of the work that we've done around making the inbox management experience better. So here I have a virtual machine, and I'm using VM Connect, just the inbox management tools. And we actually spend a lot of time talking to people, trying to understand why and when they use what tools. You know, hopefully you're aware we have the inbox management tools, Hyper-V Manager, VM Connect, and then we have System Center and System Center Virtual Machine Manager. And one of the conversations that we're constantly having is we don't want to waste time investing in the wrong area or in the wrong tools. So whenever we look at doing some work on the inbox management tools, one of the first questions we ask is this something that would be better off being in System Center? So we spent a bunch of time going around and talking to people, trying to understand why and when do they use the inbox management tools. And so I've talked to customers who, like really large deployments, use System Center Virtual Machine Manager for everything. And I say to them, so you guys never use the inbox management tools, right? And they're like, no, we use the inbox management tools. It's like, okay, well, why? When? And the answer that came back really consistently was, even in large deployments, you use the inbox management tools to troubleshoot a box that's gone wrong. Now, if something's gone wrong with a box and you need to go into the data center and interact with it manually, or it's not responding to remote management, that's where you're going to use the inbox tools. So interesting. So digging into that, let's understand that a bit. So first thing, what's the most common reason why you have to go and troubleshoot a box, why you're sitting at the console using the inbox management tools? Well, the most common reason is networking is broken. For some reason, networking no work, and I have to interact with this box directly. Okay. So you can see I've actually set up my system here to demonstrate this. My host is on a private network. My virtual machine is disconnected. Networking broken. So then the conversation becomes, well, in this scenario, what do you like and what don't you like? And the what do you like was really simple. People really like the fact that VM Connect always just works. No matter what's going on, I can get access to what's happening in the virtual machine, and it always just works. The what don't you like kind of amused me, because it's one thing when you ask a question like that, and you get a lot of people yelling at you about this one big issue. It's another thing when you ask a question like that, and everyone kind of comes in with their own little pet peeve. Well, I don't like this, and I don't like that, and so on. So this was a case where I asked, and everyone came in with the same little pet peeve. I'm like, really? Like, is that the thing that bugs you most? The answer came back was, what bugs me most is that I can't copy and paste data into a virtual machine. So let me just show you. We can now copy and paste data into a virtual machine. Side note, I don't know if you saw this. I did this demo in TechEd Australia, and the register actually wrote up and said, only for a room full of server administrators would you get applause for demonstrating copy and paste. So I'll have to shoot them an email and let them know that it happened in New Zealand too. So I can copy and paste data, but I can actually go beyond that. I can copy and paste files in both directions. And I'll be honest, this is just showing off. We actually can now do full video and audio inside of a Hyper-V virtual machine. So let's bring this up. See if we've got sound. Yay! So there we go. And this is just standard Hyper-V, no special tricks or what. So, how is this working? How is this possible? Well, what we've done in this release is we worked very closely with the remote desktop team to allow you to use remote desktop services to connect to a virtual machine directly over VM bus, even when there's no network. So what I've just shown you works when the network's down, when the virtual machine's on a different network. It'll work if this virtual machine's running on a server core instance back in my data center and I'm connected to it remotely. Anytime the virtual machine's running, we can now get a remote desktop session into it and get all the integration that comes with remote desktop. So, let me hit the right button. I swear, if you haven't seen this, there are like 30 buttons up here on the switcher, and I have been told to hit one. And if I hit the wrong one, it will be the end of the world. So I'm not going to go through all of this. I've really put this here so that when you guys get a copy of the deck afterwards, you can look over it. This is all the details of the differences between Generation 1 and Generation 2 virtual machines. A couple of things I want to be really clear about with Generation 2 virtual machines. The first one, and I should say this 3 times because everyone gets caught up on this. We haven't done any features that are Generation 2 virtual machine specific. So the benefits of Generation 2 virtual machines in this release are secure boot, boot from SCSI, and boot from virtual network adapter. The cool enhanced mode VM Connect, that works for Generation 1 and Generation 2. All the other features I'm going to show you, that works for Generation 1 and Generation 2. I swear, every time I do this presentation, someone comes up at the end and says, well, I want to use feature X, and that's a generation 2 only thing, isn't it? No. No. This is my last presentation of a run of trade shows, so I may punch you if you do that to me. Do not come up to me and say, like, oh, that feature's generation 2 only. No. The other thing that happens is people come up and say, like, generation 2 virtual machines, they'll be, like, so much faster, won't they? Well, not really. We've actually done a lot of work performance tuning virtualization in general. And even with the generation 1 virtual machine, the performance overhead is now in the 5% vicinity most of the time. So even if we halved the overhead, we would be going from 5 to 2%. There are a couple of interesting areas where generation 2 virtual machines are faster. The first one is boot time. Generation 2 virtual machines tend to be about 15 to 20% faster to boot. The other one is actually operating system install is insanely fast inside of generation 2 virtual machine. If you get the 2012 R2 bits, it's a fun experiment to do. Just set up a generation 1, generation 2 virtual machine side by side and go through and kick off the OS install, and you'll see that the generation 2 virtual machine screams ahead. The next thing I want to do is I want to quickly step through how the enhanced mode Virtual Machine Connect looks like under the covers. So the traditional VM Connect that we have, you have applications in the guest. They're writing to and reading from video, keyboard, and mouse. That gets trapped by Hyper-V and sent over VM bus into the parent partition. Here we take the information and we create a big old frame buffer, which is basically just a bitmap of what got drawn to the screen, and we send the bitmap out, we take keystrokes and mouse in, and that's the experience that you get. It's the basic experience, but it always works. Now, interesting point to make is that with the basic experience, this connection here is actually already using the remote desktop protocol. So we're using the remote desktop protocol here, but then we're just feeding it a bitmap and pulling out the keystrokes and the mouse information. With enhanced virtual machine control, it actually looks kind of the same. However, instead of using the video driver in the guest, we're now using remote desktop. And we're sending that over VM bus. And we're sending that to VM Connect. And we're now able to do end-to-end remote desktop. And what you get, experience-wise, is a remote desktop session. But you also get the robustness and availability of virtual machine control. So, pretty cool. So that's some of the forward-looking stuff. The other thing, which hopefully comes as no surprise to anyone in this room, is that we did a lot of work to make Hyper-V better for private cloud deployments. If that comes as a surprise to anyone here, then you need to leave. You're in the wrong session. So we did, 2012, great release. We've got a lot of people doing private cloud. But, straight away we turn around and go, okay, what can we do to make Hyper-V even better, make the next release even better for private cloud? So just a warning, there's a whole bunch of features I'm about to go through. So the first thing we looked at was, well, since 2012 is such a great release, we know there are a lot of people out there deploying 2012. We want to make sure that we don't slow down the momentum by coming out and saying, hey, here's 2012 R2. In my case, because I knew I was going to be the guy who got to announce 2012 R2 Hyper-V at TechEd US, I knew I didn't want fruit thrown at me on the stage from all the people who were halfway through a 2012 deployment. Honestly, when we started working on planning for 2012 R2, I was sitting in a room with my developers and testers, and I was saying, I'm going to go to TechEd US next year, and I am going to announce 2012 R2 Hyper-V, and in that room is going to be a guy who was halfway through his 2012 deployment and came to TechEd just to kind of get deep details on 2012, and he is going to be pissed at me, and I need to have an answer ready for him. So we now support cross-version live migration. So you can take a 2012 deployment, you can live migrate virtual machines from 2012 to 2012 R2. This includes shared nothing live migration. This includes cross-cluster live migration. So, if you have deployed 2012, if you're halfway through a 2012 deployment, it's fine. You'll be able to get to 2012 R2. with zero downtime. The next thing that we did was we invested in making live migration faster. I'm not going to talk about this much here. I want to talk about it as I'm showing you a demo and some more details later on. We also added the ability to do online VHDX resize. So you can now have a running virtual machine with a VHDX file, and you can increase it. You can also decrease it. Now, one of the things that we have done for pretty much every release of Hyper-V, and I'm sure I'm going to be doing this for the next 5-10 years of my life, is every release of Hyper-V, we basically go out and we say, okay, why do you need to turn VMs off still? Okay, let's go and make that work online. I like to tell the team that when it comes to server administrators and uptime, it's like kids and candy. You just can't give them enough. And every time we make something new possible to do while the virtual machine's running, the next thing just becomes a pain point. So now you can resize virtual hard drives while it's running. We also added the ability to export a virtual machine or clone a virtual machine while it's running, which is kind of handy. And I'll talk more about that in a moment. But first, I'm going to switch across to a demo. And I will apologize. I am going to use a video for this because I need a fairly sizable lab infrastructure, which I don't have with me. So let me bring this up. OK. So here I have my System Center Virtual Machine Manager, and I've started a live migration. There are a couple of things that I want to call out here. The first thing is I'm demoing this in System Center Virtual Machine Manager. First time I've ever been able to do that, because this is the first time that we are shipping System Center and Windows Server at the same time. I am so happy that we are finally doing that. For too long, it's been a case of we ship Windows Server, 6 months later we ship System Center. Windows Server 2012 R2, they both ship together at the same time. So I'm using System Center Virtual Machine Manager, and I've started live migrating a virtual machine. You can see from the little text here, this is just 2012 to 2012 live migration, and I'm doing this to set a baseline. While this is happening, let me kind of step you through my infrastructure. This is actually my personal test lab that I have set up at Microsoft. You can see that I have 2 clusters. Let me get my little laser pointer. I have Boeotia, which is a 2012 cluster, and I have Mount Helicon, which is a 2012 R2 cluster. Now, this is not fancy hardware. So I am a program manager at Microsoft. We're involved in talking to customers, figuring out what features we're going to work on. Most of our life is spent in Word, unfortunately. I spend far too much time in Word and Outlook. And the result is I don't get the best hardware in the world. I like to say we do get a lot of hardware from partners, and it first goes to the dev team, then it goes to the test team, then it goes to the dumpster, and then I fish it out of the dumpster and put it in my lab. So just pause. We did the first live migration. It took about 66 seconds. We're now live migrating this virtual machine from 2012 to 2012 R2. So the infrastructure I'm doing this on is just, honestly, it's a bunch of desktop computers. I've got a bunch of single processor Core i7 boxes. They've got 16 gig of RAM in them each. They've each got 4 1 gigabit network adapters, and I'm using teaming. So really nothing fancy. So we're going to live migrate this virtual machine. It's gone from one box to another in 2012. Now we're going to go from 2012 to 2012 R2. And without changing any of the hardware, we're going to live migrate it again from 2012 R2 to 2012 R2. And this is going to show off the first way that we've made live migration faster in 2012 R2 is through live migration compression. Now, the great thing about live migration compression is it gives you faster live migration on the hardware you already have. So there we are. We've done the cross-version live migration, 66 seconds again. And now we're going to do a live migration, same hardware, but with compression. You're going to see how much faster it gets. Once that's finished, I do a fourth and final live migration, which is live migration over a different network. I actually have, because I don't get much hardware, I have just 2 cards and a crossover cable so that I can show you live migration over RDMA, which is the other feature that we've added in 2012 R2. So for most people, RDMA means you have to buy new hardware for that. So first, the compression, 18 seconds. So we went from 66 seconds to 18 seconds on the same hardware. My script is doing some things to change things around so we can do RDMA. But I love, when we released the preview, I actually had one of our MVPs tweet me and say, hey, Ben, thanks for the free network upgrade. Because that's what he felt like. I've deployed this, and now live migration is faster. But remembering, 66 seconds, 18 seconds, we're now going to do the live migration over RDMA. And, drum roll. Eight seconds. So 66 seconds to 8 seconds. So I'm going to cut this video short. Now Demo is doing online resize and online export using SCVMM, but I will run out of time if I show that. So let me switch back here. So let's talk a bit about some of the things I've just talked about, some of the things that I've shown. So cross-version compatibility. We set out to make cross-version live migration work. That was our goal. And it was one of those happy cases where in making cross-version live migration work, we made cross-version pretty much everything work. So cross-version save states, cross-version snapshots, it all works. So doing upgrades in the past used to be a real pain. It's going to be a lot simpler going from 2012 to 2012 R2. Now let's talk about some of the stuff with faster live migration. So the first thing that I showed you was compression. Now, it's a bit hard to estimate how fast compression is going to be, because how fast compression makes things is really a factor of how much CPU is available in your computer for us to do compression with, and how complicated is the memory in the virtual machine that we're trying to live migrate. So one of the things we've noticed that even once people have consolidated with virtualization, most systems out there are still drastically underutilizing their CPU. Most people that we talk to, even after they've gone through and done massive consolidation with virtualization, their physical systems are still only in like the 30% CPU utilization kind of ballpark. That said, we did want to be really careful with this to make sure that we didn't affect the performance of the system. So we actively monitor the CPU load, and we will throttle ourselves back. Worst case scenario, if your computer is absolutely pegged on CPU load, we just won't engage compression at all. We've done testing with active SQL workloads, and what we've seen, generally speaking, is that compression gives you a 2 to 3x performance improvement. That's what you can typically expect to see. Now the RDMA one, this is the really fun one. And the key message that I have here is, if you're designing a new private cloud deployment and you want to have like just the premium experience, you need to be looking at RDMA hardware. So the way that we did RDMA was we've actually built live migration on top of SMB Direct. This means not only do we get the RDMA hardware capabilities, but we also get a lot of stuff from SMB, like we now have multi-channel support. And when we started building this, we honestly had no idea how fast it was going to be. And so once we got it up and running, we actually set up a couple of boxes in our lab, and we went, okay, what we're going to do, we know we've got multi-channel in here, we know we've got RDMA in here. We are going to just keep on putting in adapters and see what bottlenecks we hit, and see how fast we can make this. So we started off with single adapter, dual head, crossover cable. Did some performance profiling. We added second adapter, it got faster. So we've now got 2 on either side. We added third adapter, nothing. Didn't get any faster. So we did some system profiling, trying to figure out what was happening. Turned out we were bottlenecking on the PCI bus. So keynote here, if you're serious about performance with RDMA, you need to have systems with PCIe 3.0, not 2.2. So we actually had to get rid of those systems because they were PCIe 2.2, get in some systems that were PCIe 3.0. We started going again, 1 adapter, 2 adapters, 3 adapters, saw a boost. We put in 4 adapters, we didn't see a boost. Okay, we've hit a new bottleneck. So we did a whole bunch of profiling, and we realized that in going from 3 adapters to 4 adapters, we were now bottlenecked on the speed of memory in the servers. We were transferring data between these servers at a rate of 16 gigabytes a second. That's just insane. That is really cool. So you might be sitting here going like, okay, Ben, that's cool, but why do I care? Yeah, you showed a live migration, 66 seconds, 18 seconds, 8, fine. 66 is pretty fast. Not much you can do in 66 seconds. That's not the scenario we care about. The real scenario, the real reason why people use live migration is you have an 8-node Hyper-V cluster. Each node has 128 gig of RAM, and in order to patch that, you have to live migrate every virtual machine in the system. Now, we've done the math, and we've heard this from customers, that doing a patch deployment with live migration at that scale takes about 10 to 12 hours. And there are some customers out there, and God bless you if you're one of them, that you have enough confidence in our platform that you'll just go like, oh yeah, Microsoft has automated tools for this, I'll kick it off overnight and I'll go home and sleep easy. As I said, more power to you if you're one of those people. But most people I know will babysit that process. Most people I know will start that process by sending out an email to all their team going, attention everyone, we are about to patch the cluster. Hands off we are entering a maintenance window. And now you're going to spend the rest of the day just sitting there staring at the screen going like, still going, okay. That's a bad day, that's not fun. So, if it took 12 hours before, with compression, it now takes 4. We just went from a full day with overtime to an afternoon. With RDMA, it's now under an hour. It's now something you can do in a lunch break without needing to tell people, hands off the cluster. So some guidance here. In this release in R2, it's an either-or choice. You can have compression, or you can use SMB direct. You can't do both. We've done a lot of profiling here, and our general guidance is, look at how much bandwidth you have available for live migration. If it's under 10 gig or less, use compression. If it's over 10 gig, then use SMB direct. That's a very simple rule of thumb to follow there. So now I want to talk about more things that we've done. I sound like an infomercial person, but wait, there's more. So we've done a lot of work making Linux better as a guest operating system. So we've got full dynamic memory support. This is both hot add and remove of memory. It's the whole thing that you get on Windows now on Linux. We do online backup. This is awesome. Linux doesn't have a great backup infrastructure and ecosystem. On the Windows side of things, we have VSS. We're used to having, great enterprise backup tools. But in the past, if you had Linux virtual machines and you tried to back them up using an enterprise backup tool, they'd be taken offline. We now have written code that runs inside of Linux, and it does a file system freeze for us. And what this means is it means that you get zero downtime backup of your Linux virtual machine that is file system consistent. It's not application consistent, so if you have databases or stuff like that, you still have to think about what you're doing with that. But Linux doesn't have a general purpose application consistent backup infrastructure. So that's actually fairly typical for what you get for Linux. We've made sure that the online VHDX resize functionality works with Linux. And we've also developed a new video driver for Linux. The next thing we've done is we've done a lot of work on storage costs. If we go out and we talk to people today about Hyper-V in their environments, about their private cloud environments, one of the top things we hear is that people run out of storage bandwidth. One of the top causes of performance issues, one of the top causes of scalability issues is I don't have enough storage bandwidth to keep everything running happily. So we've done a lot of work here. We have a feature storage quas where you can now control and shape the storage bandwidth. We've also put in a whole lot of counters where you can see what's happening, gather historical data. We've added a new feature which is called guest clustering with shared VHDX. This is actually really powerful. So what this allows you to do is it allows you to put a VHDX file on either a CSV volume or a scale-out file server, and then use it to create a guest cluster that is enterprise-grade. So, quick show of hands. How many people here have guest clusters in their environment today? Just a small number. So, you guys know that in order to do this today, you had to set up storage just for that environment. You had to set up LUNs, you had to set up ice guys, you had to special case the storage for that environment. With this functionality, no more. With this functionality, whether it's clustered or not, your storage is VHDX files, either on a CSV volume or a scale-out file server. And creating a guest cluster is now just checking a box on the virtual machine settings. The final thing we've done is we've done a bunch of investments in Replica, which I spoke at depth in earlier this morning. So I now have 13 minutes, and I have 13 minutes of demos. So we're going to just try and cherry pick and see what demos we can get through in the time that we have. So here we are, my lovely little system. First thing I want to show you, I'm not going to show you all the Linux functionality because I don't have enough time, but I do want to show you dynamic memory. It's a fun little demo here because one thing that I'll highlight is I'm running all these virtual machines on an IBM X220 ThinkPad with 8 gig of RAM, and it is well and truly out of resource. So you can see here, this system booted with 1 gig of RAM. It's currently down to 698, so we've ballooned that memory out. There is not a spare meg in the system, but I have set this virtual machine, I've marked it top priority to dynamic memory. I've said, if anything else, this virtual machine gets memory. So I have a nice little program that all it does is it allocates memory and sits on it. So I'm going to run this, and if you watch down here, you're going to see the memory demand pop up. A moment later, memory assigned. If you watch closely in the assigned column, you're going to see that we're pulling this memory out of all the other virtual machines in order to make this work. And I'm just going to keep on going. And my poor little VMs are all getting beat up for this. But I actually think this is really cool because it shows you dynamic memory in action. Let's see, who are we going to beat up to get some memory out of? I'm getting impatient. I know that if I push this too fast, my program will actually fall over. Thankfully, it frees memory when it does. There we go. We got some more memory. Someone gave it up. Let's just take more memory. You shouldn't do this to your system, by the way. This isn't kind. So let's see. I'm going to push it in my program. Yeah, there we go. We've really pushed it up, see if we can get some more memory. Okay, we're stealing more memory. Okay, now we're going to free, and in about a second, my system will steal that memory back and go, everyone has memory again. So, but that's really cool. It's exactly the same functionality on Linux as you got on Windows with dynamic memory. So let's put that away. I'm going to quickly pull up. This is a virtual machine that I have configured using the shared VHDX functionality. If I log in here, you can see this is a 2-node cluster. I've got a quorum disk. I've got a clustered shared volume. But if I go into the settings, you're going to see these drives are actually just VHDX files on a scale-out file server. Our opinion is this now makes guest clusters viable. And it's something that I'm going to be pushing in the next year or two is, when I'm out talking to people and talking through their deployments, if I hear anyone mention I'm running a SQL server, I'm going to be saying, is that clustered? And if they say no, I'm going to say, why? Because, come on, if we're honest with ourselves, the only thing that stops us from clustering these workloads is that it has been hard. Well, it is no longer hard. It's been expensive. Well, it is no longer expensive. It is now easy. It now uses the same storage that you have, and you can get a higher level of protection for your workload. So let's put that away. Now I'll show you some of the storage I/O stuff. This is a fun little demo. So I'm going to pick on someone. I'm going to pick on you. What's your name? Dan? Okay, so we have Dan here. Dan is a service provider, and I have bought a virtual machine from Dan, and I'm paying the princely sum of $30 a month for this virtual machine. I'm getting some services from Dan, and it's a Thursday afternoon, and I have some number crunching that I need to have happen in my database. So I'm going to start a big calculation in my database in this virtual machine. And there it goes, happily going away. And now that I've kicked this off, I know it's going to take a while, so I'm going to go out and get a coffee. So I'm happy. My workload's running, it's going to take a while, and I'm having coffee. I like coffee. And right now, Dan is happy, but he is about to not be happy. Because in 3 seconds, Peter? In 3 seconds, Peter also has bought a VM from Dan for the princely sum of $30 a month. And Peter has just noticed that his VM's performance has ground to a miserable halt. Everything he does is now taking minutes. And Peter is about to pick up the phone and start yelling at Dan about how bad his performance is. Now this happens. And the sad thing is, I have talked to people on both sides of the fence when this happens, and I happen to know I'm not discrediting Dan at all. I'm sure you're a lovely guy, Dan. But I happen to know that 9 times out of 10, what Dan is going to do in response to this is turn my VM off. Because that's the only thing he can do today. And it's the great mental calculation. Like Dan's going like, okay, I've got 9 people screaming at me about bad performance, and if I turn this VM off, then I have 1 person screaming at me, and 1's better than 9. But let's be honest, that's not a great story. This hasn't been a great experience from Dan because he's got all these people screaming at him. It's not going to be a great experience for me because I'm going to get back from my coffee, and what the heck's happened to my virtual machine? So at 2012 R2. Dan's going to get the call, and then he's going to be able to come in here and go, okay, this virtual machine, I don't know what it's doing, but I don't like this. So I'm going to come in here, and I'm going to cap the virtual machine. And immediately, with 0 downtime, peace and harmony is restored. I come back from my coffee, and oh man, it's only halfway through. Okay, well, I'm heading home for the day. No big deal for me. No, but for Dan, this has been great. And if Dan was a forward-thinking man, which I trust he is, he will have actually set up the minimums on the other people's virtual machines so that they would have been protected from this in the first place. So let me just turn that off so I don't get tripped up by that. There we go. Nice little workload. So that's a cool feature. The final thing I want to show, I've got 5 minutes left. Final thing I want to show is some of the improvements that we've made to Hyper-V Replica. I apologize if you were in my replica session this morning. This is going to be a little bit of overlap. So I have a virtual machine here, and I'm going to go ahead and enable Hyper-V Replica. Going to send it to Replica 1. So the first change we've made is in 2012, we always sent replications every 5 minutes. This was a fixed thing. In 2012, we specifically designed for people who were trying to do replication over, say, a commercial broadband link. And sending it every 5 minutes is a good thing. But we actually had people come back and ask for us to do both shorter and longer replication frequencies. So we've added that. I can now configure this. I can say 30 seconds. This is for the people who said, we want to use replication inside our data center, from one side of the data center to the other over a LAN connection. And we just want you to send that data as fast as you can. 30-second replication frequency means that at worst case, your replica virtual machine is no more than 60 seconds over, 60 seconds behind the main. The other option we have is 15 minutes. And this is for the people who said, hey, replica's really cool. Like, it's great that it works over broadband. But what I want to do is I want to do it over a satellite link. Yeah. So this is designed to run over really low bandwidth, high latency, unreliable networks. It just makes the system a lot more tolerant of failure. So I'm going to go ahead with 5 minutes. Jump through, finish that off. So the other thing that we did was we added a feature that we call extended replication. And this allows me to go to this replica virtual machine and say, you know what? Replica it on. I want to send it on to a third server. So here I'm going to send it on to replica 2. And the reason why we did this is actually kind of an interesting story. I'm just going to jump through and finish that. When we designed replica in 2012, we really wanted to build a solution where local service providers could offer DR as a service to small and medium businesses. We felt that small and medium businesses were a group of users who just did not have a disaster recovery option today, and we thought that this would be a great offering. I'll just show you, here's my extended replication information. And we released 2012, and we went out and we hit the road and we talked to a bunch of service providers saying like, hey, here's the concept. You guys gonna do this? And it was one of those kind of awkward moments, because what happened was we had a lot of service providers came back to us and said like, yeah, Hyper-V Replica, that is really cool. I really like that. In fact, I like it so much that I don't want to offer it to my customers. It's like, what? And they're like, well, as a hoster, I have SLA agreements around my virtual machines. In order to meet those SLA agreements today, I have multiple data centers and I use SAN replication, and that costs a lot of money. And I want to use Hyper-V Replica to get rid of the SAN replication, and I want to use it myself. And so they were going like, yeah, it's a great business idea that you've got, but we can save money today by using Replica internally, whereas if we offer this as a service, then we have to wait for people to sign up and so on. So we actually built the extended replication primarily so that service providers could continue to use this internally, but could also offer it as a service externally. So, question I always get asked about this, it is very specifically replication from A to B to C. That is it. It is not A to B, A to C. It is not A to B to C to D. It is not A to B to C to D to E to A. That would be bad. None of these are supported. It is A to B to C. It is a very specific scenario. So anyway, we are pretty much out of time. I have 40 seconds left on the clock. So I just want to wrap up. A couple of things to call out. One, we're just continuing to make Hyper-V better for private cloud. And I can pretty much guarantee you that next time we release Windows Server, I'm going to be on stage talking about how we've made Hyper-V even better for private cloud. Increasing virtual machine uptime is always a priority. So I love to chat to people about, okay, why are you turning virtual machines off? When does that happen? We're always listening to customers. If you look at these features, a lot of them were about listening to what you guys were doing, listening to what was and wasn't working, and trying to make things better. And the final point to make is we're really focused on innovating in virtualization. Believe it or not, when we launched 2012, I had people come up to me and say, like, so you guys are done with Hyper-V now. Like, no. And trust me, we are not done with Hyper-V. We're going to be continuing to innovate, continuing to do cool, awesome stuff. So with that, I'm out of time. I hope you enjoyed the session. I hope you enjoy the show. And please feel free to find me outside afterwards, and I'll happily answer questions.